Hello everyone and welcome back. Today we are going to look at arithmetic series. So basically there's a difference between an arithmetic series and an arithmetic sequence. So in an arithmetic sequence is actually just a normal pattern that has a term and then the next term, then the next term up until the last term. But now, what does a arithmetic series represent? Arithmetic series represent the sum of all the terms in an arithmetic sequence. So basically, all these terms are the terms of an arithmetic sequence, but now we are adding all of them. That is why they become what? An arithmetic series. So I will be correct to say now an arithmetic series is represented by the sum of all the terms in an arithmetic sequence. So there's actually a formula that is proven to us to say if ever you want to calculate the sum of all the terms in a arithmetic series, you will use this equation. Sn is equals to n over 2 open bracket 2a plus n minus 1 all multiplied by 3. So remember, like I said, this equation is actually proven. So we are just going to prove it because they will ask you in an exam question to prove how do you find the sum of all the terms in an arithmetic sequence. So now, here is a proof. So basically, when you prove the sum of arithmetic sequences, you know that in an arithmetic sequence, you have what? You have your first term as A, and then for you to get to the next term, you will have to add a constant difference, because you remember in an arithmetic sequence must have what? A constant difference between two consecutive terms. So basically, from the first term, which is A, you are going to add D to get to the next term, which is going to be A plus D. And then to get to the next term, you will also have to add D, and then you will be having A plus 2D. And then you will do that up until you get to the last term, of which you don't know what is the value of the last term. So now, do you see now, when you are here at your last term, you can basically move forward because you already know how you can represent your last term, because your last term is represented by Tn. So basically, when you move forward to get other terms in this sequence, or you can name it a series because there is an addition sign between terms, you will have to do what? You will have to subtract the constant difference because you will be moving backward. So remember, when you were moving forward on an arithmetic sequence to get to the next term, you had what? You had to add the constant difference. So you will do the reverse of that when you go backwards on this arithmetic sequence. You will have what? Let's say, for example, you want to move back. Let me just erase this one here. Let me just erase it and put it a little bit far away, because I just want to have three terms here. Let's say now your last term is what? Is Tn. And then now when you move back, you will have to do what? You will have to subtract D, which is the constant difference, because if you are at this term here, you will have to add D to get to this term, which is Tn. So if you have subtracted D and then you add D, that means you will end up with Tn. So that means the term here is going to be what? It's going to be Tn subtract D. Meaning now, when you move forward, normally with an arithmetic sequence, you will have to add D, and then when you add D here, you will be left with Tn, of which is our last term. Then when you move backwards again for the last time, you will have what? You will have your Tn what subtract 2d. Actually, I don't have space there. Please forgive me about that. Okay. So this is how you're gonna represent what? You're gonna represent the sum of all your terms in what? In a arithmetic sequence. But basically, we call this an arithmetic series. So the step of proving the equation that I showed you in a previous slide is that you will have to write this Sn, this arithmetic sum. You will have to write it in a reverse, but actually meaning the same thing. Okay, let me just make an example. Let's say, for example, you have A plus B. So basically, A plus B is still equals to B plus A. So what we're gonna do, what I'm trying to explain is that you have to write your Sn, but you'll have to write these variables or these numbers that you have here in a reverse way. Like you will have to start with Tn and then you move backward. So for us to do that, you're gonna have what? You're gonna have Sn here and then you equate here. Then you write your last term as a first term. You're gonna have Tn here. Then you will say plus. Remember, moving backward is gonna be Tn minus d. And then you're gonna have what? Plus Tn minus 2d. And then plus, remember we are still moving backwards, and then there are a lot of terms in between here. Then you will have what? You will have a plus 2d, and you will also have what? You will have a plus d, and the last term will be a. So this is what you do when the question asks you to prove the equation of the arithmetic series. So after you write your sum in a normal way and you write it in a reverse way, you just have to add these two equations. So let's add the two equations. That means we're gonna have what? We're gonna have Sn plus Sn, which is gonna be 2Sn. And then here when you add, you're gonna say A plus Tn, you're gonna be having what? You're gonna have, let's say, A plus Tn plus Tn. But be aware of something here. So in this next term, when you add them, it's gonna be what? It's gonna be A plus D plus Tn minus D. So basically, D will cancel the D out. So here you're gonna still be left with what? With A plus N. And also in this case, 2D will subtract 2D. Then also the next term, 2D will subtract 2D, and then D will subtract D. And then from all these terms, you're only going to be left with what? With A plus Tn. So basically, we don't know how many terms are in this sequence, or we can say series. We don't know how many terms. So we're just going to name it what? We're just going to say multiply this by n. Because let's say, for example, you have A plus A plus A. Let's say now we know now it's 3A's. We'll just have to say what? 3A. The answer will be 3A. So basically, when we add all the very same thing that have A plus N, it will be what? It will be A plus Tn multiplied by what? By the number of A plus Tn on this sequence or a series. But we actually don't know the exact number, so we just represent that by N. So now when you are here, you can now, let me just write it in a good way. You write your n on the other side. Let's just write here 2n. I'm just gonna say is 2Sn equals to n multiplied by a plus Tn. So for us to be left with only Sn on this side, we'll have to divide by 2. We have to divide everything by 2. And therefore, now Sn is equals to n over 2 into what? Into a plus Tn. So now remember, Tn actually represents the last term of the series. So basically, if you have the value of the last term, you can just plug it here as Tn. So you can just write the equation as to be like this: is Sn, which is equals to n over 2, and then you have what? A plus the value of the last term, which is equals to Tn. But also, at the same time, we also know now Tn is equals to what? Tn is also equals to a plus n minus 1 all multiplied by d. So you can also plug in what? A plus n minus 1 all multiplied by d in place of Tn. So your equation will basically simplify to be what? To be Sn is equals to n over 2 all into what? Into a. Remember, this is a, and then Tn is what? Is going to be a plus a again plus n minus 1 all multiplied by d. Then you close bracket. So when you simplify further, you get to the equation that I've just showed you in a previous slide, which is the equation of the arithmetic series, the sum of a arithmetic series. So it's going to be 2a plus n minus 1. Okay, let me just write like this, d here. Okay, so this is the equation that I was talking about. And also you can also find the sum using this equation here, because we know Tn represents the last term. So if you have the value of the last term, then you can substitute it there and get the sum. So this is how you prove it. But then, you know, when you write on your paper, you will have to write neatly. Please forgive me for my messy or writing not in a very clean way. So now let's look at the example here. This is an example of an exam question that you have to solve for arithmetic series. So the question says that the sum of all the first 8 terms of an arithmetic series. So you see now they have mentioned to us to say now, okay, this is an arithmetic series, and then its sum is equals to 124. So this is the data that they give us to say now the sum, the Sn of what? But now they also have mentioned us to say now this Sn, it has how many terms? It has 8 terms. So sum of 8 terms will be equals to how much? To 124. And the sum of the first 20 terms, and then also they give us what? The sum of the first 20 terms. To say 20 terms will give us how much? 910. So this is the statement that is given to us. And now we have to answer question number A and B. So the first question says that find the first term and the constant difference of the series. So basically these are 2 series, or maybe this is 1 series, but we have to find what? We have to find the value of the first term of the series and what? And the constant difference of the series. So remember, we know the equation of Sn. Remember Sn, let me just write it here. Sn is equals to n over 2 multiplied by 2a plus n minus 1 all multiplied by d. So this is the equation of the sum of all the series. So now, remember, they have told us to say now, the sum of the first 8 terms is actually equals to 124. So I will be correct if I substitute 124 here as Sn and also substitute n as 8, because this is the information that is given to us. So now let's do that. We're going to say what? Okay, Sn is 124. And we're also going to say equals to what is the value of n? N is equals to 8 over 2. Then we open the bracket. This is 2a. We don't know a. We are looking for a and d, remember? And then we also have the value of n, which is how much? Which is 8 minus 1. But we also don't know what is d. So now our equation will simplify to be 124 equals to, so this here will be 4. And then we will have 2a. Then here is going to be 8 minus 1 multiplied by d is going to be what? It's going to be plus 70, because 8 minus 1 is 7 multiplied by d. Then it's just going to be 70. Okay. Then now we can do what? We can just divide both sides by 4. Just to simplify it further, divide both sides by 4. Okay. And now 124 divided by 4 will be equals to 31. So it's going to be 31 equals to, this 4 will cancel this 4 here. Then you will be left with 2a plus 7d. So this will be what? This will be our equation 1. Remember, we have two equations. They're giving us these two equations. We only have simplified the first condition. We also have to do the other condition. So now our equation 1 is this equation. Can I just take this equation and write it here so that I have space to solve for the second equation? So let's say now our equation 1 is what? Is 31. Is 31 is equals to 2a plus 7d. And then now I can erase here. Let me erase. Let me erase here. Okay. So now on the Sn, we'll just have to substitute what? The value of Sn, our new Sn, and also which has what is 910, and also the position, which is 20. So the value of Sn for the second condition is going to be what? It's going to be 910. So we got, in place of Sn here, we're going to substitute 910. So it's going to be 910. And then in place of n, we're going to substitute 20 here. Remember, n is here, and then also n is there. So we're going to substitute 20 here, and then we're going to substitute 20 here. Then we simplify the equation. So when we simplify the equation, we're going to have what? We're going to have 910 here being equals to 20 divided by 2 is going to be 10. And then we still have 2a. Then 20 subtract 1 is going to be 19. And then 19 multiplied by d is going to be 19d. 19d. And then now you can divide both sides by 10. Divide both sides by 10 so that we can get rid of this 10. Divide by 10. Divide by 10. And then 190 divide 910 divided by 10 is going to be 91. And we're going to be left with that with 2a plus 19d. So basically now we will be having what? We'll be having two equations that has two variables. That means now we can solve this equation simultaneously. So now let's say, for example, okay, let me just write this equation here. Okay, there's actually a lot of methods that you can use to solve simultaneous equation, but in this case we'll use the easier one, the simpler one that we can use. And then now let's say here you have this and this. I will show you all the methods or when I do algebra. So it's gonna be 91, which is equals to 2a plus 19d. Okay, so let me just erase here. So basically now we have these two equations of ours, but now we have to do what? We have to solve for both a and d. So in this case, I'm just going to use elimination methods. I'm going to use elimination method because I can see now there is a variable that can cancel out. I can't use a elimination method if ever there's no way I can cancel out one variable. I can only use elimination method if I can see now, okay, now this one I can cancel 2a, I can cancel 2a if I subtract both the equation. If ever, let's say for example, I had a here, that means I will multiply all the expression at the top by 2 so that I can have 2a, and then I apply the elimination method. So basically now when I apply the elimination method, I will actually subtract this equation from this equation, or you can subtract this one from this one. It doesn't matter which one you do. So now I'm just gonna subtract here. You just put subtract. So basically what I'm gonna do now, I'm just gonna subtract this one from this one, because I can see this one at the bottom, it has bigger number, so I'm just avoiding negative number, but it doesn't matter actually. You can subtract the top one, but now mathematically to actually not have a negative, to avoid having negative answers, I will just subtract from the one that is at the bottom, which is the bigger numbers. So I will say now 91 subtract 31, so it's going to be 91 subtract 31, which is going to be 60, and then now 2a subtract 2a, they will cancel out, and then I will be left with how much? It's going to be 19 subtract 7, which is going to be 12d. This is going to be 12d, because it's 19d subtract 7d. We're going to be left with 12d. Then we divide both sides by 12. The value of d will be equal to how much? So it's going to be 60 divided by 12, which is 5. So the value of d is 5. The value of d, the difference is 5. And then now we have to find the value of a. So when we find the value of a, we just substitute the value of d in any of the equations here. So let's just use the first equation to say now we have 31, which is equals to 2a plus 7, and now we know the value of d, which is how much? Which is 5. So I'm just going to transpose this one here. It's going to be 31 subtract 7 multiply by 5 is equals to 2a, and then I will divide both sides by 2. And then I just put everything on the calculator. You can just solve step by step. Anyway, how you solve, you will get to the same answer. So it will be 31 subtract 7 into 5 divided by 2. So the value of a will be negative 2. So we have the value of d being, let me just write the value of a here. The value of a will be what? Will be negative 2. So we have calculated the value of d as 5 and also the value of a as negative 1. So we are done with number A. So number B says what? Number B says find the nth term of the series. Yeah, the nth term of the series is equals to 183. Find the n value. So now they actually are giving us the last term of the sequence, and they say now we must find the position where this last term of the series is. Yeah? So now I'm just gonna erase here. I'm just gonna erase here and explain the question again so that it makes sense. So basically on the question, they say what? Find the nth term of the series. Oh, no, not find the nth term. They say now the nth term of the series is 183. And you remember we said what? The nth term represents the last term of the series. The last term, and now they have given us the value of the last term being 183. So they have given us the value of the last term, which is 183 now. And then they say we must find the value of n. So in this case, we have what? We have the value of the last term. So we can use this shortened equation here to say Sn is equals to n over 2 all multiplied. Remember, if it's this shortened equation, it's just going to be a here, and then you say plus the last term. The last term, which is what? Which is t. And now they have given us what? Okay, so now that we have this equation of ours, remember this equation actually represents the sum of what? Of the series. But if you read the question carefully, it says that the nth term of the sequence is 183, not the sum. It's the nth term, which is what? Which is the last term, and which is Tn. So we have already represented the Tn here. So basically, we know now the equation that we're going to use is which one? Is this one of Tn, so that we can find the value of what? Of n. Is going to be plus n minus 1 multiplied by d. So the value of the last term is how much? Is 183. And then we now find what? We find the value of n. Already we have calculated the value of a and the value of d. So we just plug in everything and then we get the value of n. So it's going to be what? It's going to be 183. 183 equals to, what is the value of a? The value of a is minus 2 plus, we are looking for n, minus 1. And what is the value of d? The value of d is 5. So we'll just have to simplify and get the value. So now I'm just going to transpose this one to come this side. So it's going to actually be 183 plus 2 when it comes to that side. So it's going to be 183 plus 2, because it will change the sign. And then when you simplify here, it's going to be 5n minus 5. When you multiply, it's going to be 5n minus 5. So you can also take this 5 to the other side. That means you're going to have what? 183 plus 2 plus 5 again, which is all equals to 5n. And then you can divide both sides by 5. You divide both sides by 5. Then you just put everything on the calculator. The value of n will be equals to, let's put everything in the calculator, 183 plus 2 plus 5, all divided by 5. So the value of n is going to be what? It's going to be 38. So thank you very much.